let's dive right in. The Great Pyramid of Giza, I mean, for 4,500 years, it's just been sitting there, basically screaming, how is this even possible? So, how did an ancient civilization with none of the tech we have today build one of the biggest things on the entire planet? Well, today, we're going to try and unlock some of those incredible engineering secrets.
So to really get a handle on the pyramid's secrets, you've got to go inside, right? And get this. Not long ago, a tiny little robot camera was sent deep, deep down a hidden shaft. It gets all the way to the end and stops at this stone slab, a slab that hasn't been touched for thousands of years. So what do? They drill right through it, and the camera peeks into a space that no human has seen for 4,500 years. It's exactly this kind of mystery that makes these structures so completely captivating.
Okay, so before we get into the how, let's just take a second to wrap our heads around what they actually built. The scale is, honestly, it's hard to even imagine. We're talking about a structure that weighs 6 million tons. Yeah. Just think about the absolutely insane challenges you'd have to solve to even begin building something that huge.
Need some perspective on that number? Okay. You know the Burj Khalifa, right? The tallest building on Earth, a total marvel of modern tech. The Great Pyramid weighs the same as 12 of those. 12! And that's the puzzle here. This incredible weight wasn't put together with giant steel cranes and computers. It was done with human hands and sheer brain power.
Yeah, this was way more than just a big pile of rocks. For the people building it back then, this was, for all intents and purposes, an impossible structure. Let's look at the numbers, and you'll see just how impossible it really was. Okay, check out these stats. It's 480 feet high. The base is so big you could fit 9 football fields inside of it. 9. It's made of 2.3 million stone blocks, and some of those blocks weigh 50 tons each. And somehow, all of this was built at a perfect 51.5-degree angle. Every single one of those numbers isn't just a fact. It's a massive, massive engineering problem that needed a ridiculously clever solution. All right, so where do you even start with a project like this? Well, the very first challenge comes up before you even lay a single stone. You've got to align the whole thing. The Great Pyramid lines up almost perfectly with true north, south, east, and west. So how in the world did they pull that off with such crazy precision? And that really is the million-dollar question, isn't it? I mean, you have no compass, no GPS, no satellites. It's just you, a huge, empty stretch of desert, and you have to find true north with almost zero room for error. Seriously, how do you do that? Well, the answer is it's brilliantly simple. They looked up at the stars. By tracking the polar stars, the ones that barely seem to move in the night sky, they could figure out exactly where the Earth's poles were. And just like that, they could map out the pyramid's sides with an accuracy that is, frankly, still pretty mind-blowing today. Okay, so you've got it aligned. What's next? The foundation. And this is a big one. You just can't plop a 6-million-ton building on bumpy ground. Even the tiniest slope would be a complete disaster. That entire 13-acre base had to be absolutely perfectly flat. And their solution for this? It's just genius. They basically turned the whole construction site into a giant water level. They dug a network of trenches all around the area, filled them up with water, and then, boom, you have a perfectly flat reference line. Anything, any bit of rock or dirt that stuck up above the water level just got chiseled away. Incredible, right? And for making sure smaller areas were level, they probably used a simple but really effective tool called an A-frame level. It's pretty straightforward. A weight hangs down from the top, and if the string lines up with a mark in the middle, you know you're level. Now, just try to imagine doing that inch by painstaking inch over an area that's the size of 9 football fields. The amount of patience that must have taken is it's on another level. So, the site is aligned, the foundation is perfectly flat. Now, the real work begins. The absolutely colossal job of quarrying, cutting, and moving 2.3 million blocks of stone. We're talking about a logistical operation, a supply chain, on a scale that nobody on Earth had ever even attempted before. First things first, how did they cut all that stone? A lot of people think they just used simple copper chisels. But here's the thing. Pure copper is way too soft. It would just bend and get ruined against limestone. The real key was a brilliant bit of metallurgy. They figured out how to create an alloy, arsenical copper, which is basically an early type of bronze, and that was strong enough to carve the stone. And look, it wasn't just the crazy number of blocks they had to cut. It was their size. The granite blocks they used for the really important parts, like inside the king's chamber, some of those weighed up to 50 tons. So how do you even think about moving something that weighs 50 tons?
Let's put that 50 tons into perspective again. A single one of those blocks weighs about the same as 3 passenger buses. Now imagine you have to move thousands of them, with no engines, no trucks, no cranes, just people. That was the epic transportation problem they were facing.
So how'd they do it? Well, they set up this incredible supply chain. The best limestone was actually quarried 250 kilometers away in a place called Tura. From there, armies of workers would load these massive blocks onto boats. They'd sail them down the Nile to the Giza site. Then they'd unload them and drag them up these enormous ramps into their final position. This wasn't just brute force. This shows a level of project management and organization that would honestly be impressive for a company today.
But all of that brings us to the final, and you could argue, the single most difficult challenge they faced. See, cutting limestone is one thing, but for the inner chambers, the really important stuff, the builders used granite. And granite, well, granite is a whole different animal.
And this next part is going to sound completely impossible. Granite is the second hardest stone on the planet. Only diamond is harder. Even our modern power tools can struggle with it. So how did they manage to cut it so precisely with a saw that had no teeth? How is that even possible? Okay, here's the trick. It's so clever. It's called abrasive sawing. The saw blade itself didn't do the cutting. They would drag this toothless saw back and forth across the granite. And while they were doing that, they'd pour sand into the groove. But not just any sand, sand that was full of hard minerals like quartz. And it was the friction from that sand grinding and grinding away that actually cut through the solid rock.
Just let that sink in for a second. This process was so slow. It could take up to 4 months to make a single cut through a single block of granite. 4 months for one cut. The amount of human effort, the persistence, the pure willpower that this project demanded, it's almost impossible for us to wrap our minds around it today.
So we've managed to uncover some truly amazing engineering secrets, right? We've seen how they aligned it with the stars, how they leveled the ground with water, and how they cut the hardest stone with sand. And yet, like with all great mysteries, the more you learn, the more you realize you don't know. We're still arguing about what the pyramids were really for. We can only guess how many thousands of people spend their lives building this thing. And that brings us right back to where we started, with that little robot. What did it actually see inside that secret chamber? The truth is, the search for answers is far from over. When you get right down to it, the pyramids are so much more than just old buildings. They're a giant 6 million ton monument to human ingenuity. They prove that with enough clever thinking, enough persistence, and people working together towards one goal, pretty much any problem can be solved. They're a 4,500-year-old reminder that humans are capable of making the impossible possible.